So the today topic is advanced metal cutting process. The first one is water jet machinings. It is also known as a hydrodynamic machining. Uses for fine accuracy and a high pressure, high velocity of water directed at the workpiece of the surface to causes cutting the work. These are the examples of water jet cutting machines. The source of high pressure and water enter into the valve. So valve can control and reduce the jet size by nozzles. The standoff distance water jet workpiece is a drain. The generally abrasive jet machining, the metal removal take place due to impingement of the fine abrasive particles. The abrasive particles are typically 0.025 millimeter diameter and their discharge of pressure several atmosphere. These are the examples of air and particle streams. This is called as downward directions. The approximate distance of 0.08 mm and velocity 150 to 300 meter per second, 0.3 mm to 0.5. These are the workpieces. Abrasive jet machinings, examples of abrasive jet machinings images. Next one is ultrasonic machining process. This is one of the metal cutting process. Basically, the ultrasonic machining process involves a tool made of ductile or tough materials, vibrating with a low amplitude and very high frequency and continuous flow of an abrasive slurry in small gap between the tool and workpiece. The tool is gradually fed with an uniform force. The impact of hard abrasive grains fractures the hard and brittle workpiece, resulting in the removal of the work material in the form of small wear particles. The tool material being tough and ductile wear out much slower rate. These are the examples: the feed force acting on the tools material removal, the ultrasonic vibrator 20 Hz, amplitude 15 to 20 muses. This is the abrasive slurry. These are the workpieces. The summary of these machines: the mechanics of material removal, brittle surface caused by impact abrasive grains due to the tool vibrating and high frequency. The medium slurry abrasive B4C, SIC, AL2O2, diamond 100 to 8 grit size. The vibration frequency amplitude 15 Hz, 25 to 100 muses. The tool material soft steel 1.5 for the workpieces, 100 for glass workpieces. Gap made in 25 to 40 muses. The critical parameter of frequency, amplitude, tool material, grit size and abrasive material, feed force, slurry concentration, slurry viscosity. The materials applications, material metals and alloys, particularly hard and brittle, semiconductor, non-metals and glass ceramics. Shape of applications, round and irregular holes, impressions. Limitations, very low material removal rate, tool wear, depth of holes and cavity small. Next one is EDM, electrical discharge machining. The electrical discharge machining is also known as a spark over initiated discharge machining, spark erection machining, or simply machines. It's probably the most versatile of all electrical machining methods. Mechanics of material removal, materials, melting and evaporation aided by the caviations. This process may be used in the machining parameters and any materials irrespective of its hearts which an electrical conductors. Electrical discharge machining, the rate of metal removal and the resulting surface finish can be controlled by the proper variations in the energy and duration of spark discharge. A liquid dielectrical like paraffin or some light oil, like transformer or kerosene oil, is always used in the process. The electrical discharge machining schematic diagram of EDM: the rectifier, power supply, the current controlled, servo controlled, workpieces, dielectric fluid, tank and movable electrode up and down based on the workpieces. schematic diagram of VDM, another servo control movable, warm electrode. These are the spark melted workpieces slowly, dielectric fluid workpieces. These are the advanced metal cutting process